Hello everybody. In this lesson we will be studying about trigonometric ratios. We will be studying what trigonometry is and where these trigonometric ratios are used and how they can be used in solving problems. So welcome to the lesson. Suppose the students of a school are visiting Qutub Minar. Now, if a student is looking at the top of the Minar, a right triangle can be imagined to be made as shown in the figure. Can the student find out the height of the Minar without actually measuring it? Let's look at this figure. Suppose a girl is sitting on a balcony of a house located on the bank of a river. She is looking down at a flower pot placed on a stair of a temple situated nearby on the other bank of the river. A right triangle is imagined to be made in this situation as shown in the figure. If you know the height at which the person is sitting, can you find the width of the river? Suppose a hot air balloon is flying in the air. A girl happens to spot the balloon in the sky and runs to her mother to tell her about it. Her mother rushes out of the house to look at the balloon. Now, when the girl had spotted the balloon initially, it was at point A. When both the mother and daughter came out to see it, it had already traveled to another point C. Can you find the altitude of B from the ground? In all the situations given above, the distances or heights can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. The word trigonometry is derived from the Greek words tri, meaning three, gon, meaning sides, and metron, meaning measure. In fact, trigonometry is the study of relationships between the sides and angles of a triangle. So in this lesson we will study about that relationship between the sides and angles of a triangle. We will first begin by studying the trigonometric ratios. We all have studied about right triangles and we know AC is the hypotenuse of the triangle. Let us consider the triangle ABC and let's look at angle A. From the reference point of angle A, BC happens to be the side opposite to angle A. And of course, AC is the hypotenuse. And AB is the side adjacent to angle A. So we know from in reference to angle A, we can label the three sides. Note that if the angle in reference changes, for example, now if we consider angle C as the reference angle, the sides will change. AB will become the side opposite to angle C. BC will become the side adjacent to angle C. And AC remains the hypotenuse. We will understand trigonometric ratios taking angle A as the reference angle in the triangle ABC. So let us see what these trigonometric ratios are. So looking at the triangle ABC, angled at 90 degrees at angle B, taking angle A as the reference angle, AB will be the side adjacent to angle A, BC will be the side opposite to angle A, and AC is the hypotenuse. We get the following trigonometric ratios. You know what's a ratio? A ratio is nothing but a fraction. So sine of angle A is given by the ratio side opposite to angle A divided by the hypotenuse. And what is that going to be in reference to the triangle we have? It's going to be BC over AC. Similarly, let's look at the other ratio, trigonometric ratio. Cosine of angle A is given by the ratio side adjacent to angle A divided by the hypotenuse. And what is that going to be? It's going to be AB over AC. And another trigonometric ratio, tangent of angle A is given by the ratio side opposite to angle A divided by the side adjacent to angle A. And what is that going to be? It's going to be BC over AB. The three fundamental trigonometric ratios, sine, cosine, tangent. We will look at what their reciprocals are. Let's look at the other three trigonometric ratios. Cosecant of angle A is nothing but the reciprocal of sine of angle A. We already looked at what is sine of angle A. Sine of angle A was BC over AC. So cosecant of angle A will be AC over BC. The reciprocal of sine is called cosecant. We have already looked at what is cosine of angle A. Now the reciprocal of cosine is secant of angle A, which is going to be AC over BC. So secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. And we know what the tan of angle A is, tangent. Reciprocal of the tan is cotangent, which is going to be AB over BC, adjacent over opposite. It's very easy to remember. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of the tangent. So we have 6 fundamental trigonometric ratios. So let's look at all the 6 trigonometric ratios in one perspective. Sine of angle A is opposite over hypotenuse. Sine of angle A in short is also written as sine A. Keep in mind, it is not sine times A, it is sine A. Without the angle, the sine has no meaning. So therefore, it is sine A. Cosine of angle A is adjacent side over hypotenuse. The short form of that is written as cosine A. Tangent of angle A is opposite side divided by the adjacent side, written as tan A. Similarly, cosecant of angle A is nothing but the reciprocal of sine, which is opposite hypotenuse over the opposite, written as cosecant A. Secant A is the reciprocal of cosine, that is hypotenuse over adjacent side, written as secant A. And cotangent is the reciprocal of tangent, which is adjacent over opposite, written as cot A. So these are the 6 trigonometric ratios that you need to remember: sine, cosine, tangent, cosecant, secant, cotangent. So based on this, we will be looking at how to solve problems using these trigonometric ratios. Let's try this problem. Given tan A is equal to 4 over 3, find the other trigonometric ratios of angle A. So let us first draw a right angle triangle at 90 degrees at B. What is tan? It is nothing but opposite side divided by the adjacent side. The reference angle over here is angle A because it says tan A. So from angle A, which is the side opposite to angle A, it is BC. So what is the length of that side? 4. What is the adjacent side from angle A? It is going to be AB. What is the length of that side? 3. Do we know what is the length of the hypotenuse AC? We don't know. So we need to find the length of the hypotenuse AC. Can we use Pythagoras theorem? We can. So remember the Pythagoras theorem, x squared is equal to 4 squared plus 3 squared. So x squared is going to be equal to 16 plus 9. So x squared is going to be equal to 25. Take square roots on both sides and x is going to be equal to 5. So now we know the length of the hypotenuse is 5. So we know all the three sides of the triangle. Can we now figure out what is sine of angle A? Sine A. What is the ratio? It is opposite over hypotenuse. Opposite side is 4, hypotenuse is 5. What is cosine of angle A? It is adjacent side over hypotenuse. Adjacent side of angle A is 3, so 3 over 5. And of course, we know what's tan. Tan is already given in the question, which is 4 over 3. What is the reciprocal of sine? Cosecant. So, cosecant of angle A is nothing but the reciprocal of sine, which is 5 over 4. What is the reciprocal of cosine? It is secant. So, secant of angle A is nothing but the reciprocal of cosine. So, 5 over 3. What is the reciprocal of tan? It is cotangent, cot A, which is 3 over 4. So, from one ratio, trigonometric ratio, we are able to figure out all the other trigonometric ratios for angle A. Similarly, you can take up angle C and figure out what will be the trigonometric ratios if we take angle C as the reference. So, great going. It's pretty simple. Find out the hypotenuse and figure out all the ratios depending upon the sides. Let's try this. If angle B and angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. So, let's take up two triangles first, triangle ABC and triangle PQR, where angle B is equal to, we have to prove that angle B is equal to angle Q. And sine B is going to be, we know sine, opposite over hypotenuse, AC over AB. So, then we have sine B as AC over AB. What will be sine Q? Is going to be PR over PQ. So, sine Q is equal to PR over PQ. The question says sine B is equal to sine Q. So, therefore, AC over AB is going to be equal to PR over AQ. Can I write the same thing? I can bring PR over here and AB over there. It's the same thing. So, I will write AC over PR is equal to AB over PQ. Let's label those things as equal to K. Let's label this as our equation 1. So, in other words, AC over PR is equal to K, AB over PQ is equal to K. So, we have AC over PR is equal to K and AB over PQ is equal to K. Considering the triangle ABC now, using Pythagoras theorem, what will be BC equal to? It's going to be equal to square root of AB squared minus AC squared. Use Pythagoras theorem. So, BC is going to be square root of AB squared minus AC squared. Coming to triangle PQR, what will QR be equal to? Pythagoras theorem, square root of PQ squared minus PR squared. So, QR is going to be square root of PQ squared minus PR squared. Take the ratio BC over QR. How much will that be? It's going to be square root of AB squared minus AC squared over square root of PQ squared minus PR squared. But observe over here, what's AB equal to? AB is equal to K times PQ and AC is equal to K times PR. So can I replace AB as K times PQ? I get, instead of AB squared, I get K squared PQ squared. And instead of AC squared, I can substitute K squared PR squared. And from here, I can simplify by removing K squared as the common factor. So if I remove K squared out, what do I get? Square root of K squared PQ squared minus PR squared. This whole thing will be divided by the denominator, which is going to remain the same, PQ squared minus PR squared. Now if I split the square roots, so it's going to be, K will come out of the square root. When K squared comes out of the square root, it's going to be K. And then we are left with square root PQ squared minus PR squared divided by square root of PQ squared minus PR squared, and they get cancelled. We are left with K. So observe now, from 1, AC over PR is equal to K, AB over PQ is equal to K, BC over QR is equal to K. So can I say all the three ratios are in proportion? So if all the three ratios of the two triangles are in proportion, what can we conclude? That the two triangles are similar. If the two triangles are similar, can we say that angle B is equal to angle Q? So we have proved the question. Let's try this. Consider triangle ABC right angled at C, in which AB is 29 units, BC is 21 units, and angle ABC is equal to theta. Theta is a general form of labeling an angle. It's a Greek letter. An angle is represented as theta. Determine the values of cosine squared theta plus sine squared theta. So we know AB is 29, BC is 21, but we don't know AC. Can we figure out what AC is? How do you do that? We use Pythagorean theorem, Pythagoras theorem. So AC is going to be square root of AB squared minus BC squared. So what's that going to be? Plug in the values. AB is 29, so AB squared, 29 squared minus 21 squared. For easy simplification, this is in the form A squared minus B squared, which can be written as A plus B, A minus B, and then simplified. So when you simplify that, you get 20 units. So now we know AC is 20 units. So once we know AC, can we now find out what's sine theta? It's going to be opposite over hypotenuse. Opposite of angle B is 20 and hypotenuse is 29. What will be cosine theta? Adjacent over hypotenuse. Adjacent is 21, hypotenuse is 29. So cosine theta is going to be this. Therefore, what is going to be cosine squared theta plus sine squared theta? Take these values and square them, simplify, and what do you get? Cosine squared theta plus sine squared theta is going to be this. Cosine squared 20, sine squared is 20 over 29. It doesn't matter which one comes first, and then simplify and you get the answer as 1. So remember, this forms a standard value. Cosine squared theta plus sine squared theta will always be equal to 1. Why? Because the trigonometric ratios, as long as the angle is the same, the lengths of the sides don't matter. So as long as the angle remains the same, irrespective of the length of the sides of the triangle, the ratio will remain the same. The value of the ratio will remain the same. So what's cosine squared theta plus sine squared theta equal to? 1. So pretty simple. Can you try what is cosine squared theta minus sine squared theta will be? We already know what's sine theta from this. 20 over 29. We know what's cosine theta, which is 21 over 29. So can you figure out what's going to be cosine squared theta minus sine squared theta? You can pause the video, take your time, do the calculations and check. Okay, here we go. I'm going to display to you the answer. 3, 2, 1. Cosine squared theta minus sine squared theta is going to be 41 over 841. Just plug in the values, do the calculations, and you get the answer. So when the lengths of the triangles are given, we know how to find out the trigonometric ratios and do various calculations based on these ratios. Let's try this. In a right triangle ABC, right angled at B, tan A is equal to 1. Then verify that 2 times sine A cosine A is equal to 1. So what is tan A? It's opposite side over adjacent side. So tan A, that means we are taking this as the reference angle. The opposite side is BC and the adjacent side is AB. When can tan A be 1? When the opposite side and the adjacent side are the same, because when they both cancel out and they become 1. So let's label B, let's take BC as 1 and AB as 1. Can you now figure out what's going to be AC? According to the Pythagoras theorem, AC squared or AC is going to be equal to square root of BC squared, which is 1 squared, plus AB squared, which is 1 squared, and that's going to be square root 2. So AC is going to be square root 2. Now, what is going to be sine A? Sine A is, what is the ratio? It is opposite over hypotenuse. Opposite of angle A, BC, which is 1, over hypotenuse, which is root 2. What is cosine A? Cosine A is adjacent side over hypotenuse. Adjacent side is 1. Again, hypotenuse is root 2. What are we supposed to verify? 2 times sine A cosine A. So let's plug it in. 2 times sine A, which is 1 over root 2, times cosine A, which is 1 over root 2. And that's going to be equal to 2 times 1 over root 2 times root 2 is 2, and that's going to be 1. So this is the answer. Let's try this. In triangle OPQ, right angled at P, OP is 7 centimeters and OQ minus PQ is equal to 1 centimeter. Determine the values of sine Q and cosine Q. Can we apply the Pythagoras theorem for this right angle triangle? That's going to be OQ squared equal to OP squared plus PQ squared. If you apply the Pythagoras theorem, because OQ is the hypotenuse. Instead of OQ, can I replace it with 1 plus PQ? OQ squared. OQ, can I write it as 1 plus PQ? Why? Observe here. OQ minus PQ is 1. So OQ is equal to 1 plus PQ. Now, is this in the form A plus B the whole squared? So I can apply the formula A squared plus B squared plus 2AB and expand it, and I get this. A squared plus B squared plus 2AB equal to OP squared plus PQ squared. And PQ squared cancels with PQ squared. So we are left with 1 plus 2PQ is equal to 7 squared. How did we get that 7? because the question says OP is equal to 7. Now we have, if you simplify, what do you get? PQ is going to be equal to 24. So we know PQ is equal to 24. So what will OQ be equal to? PQ is 24. So when PQ is 24, OQ is going to be equal to 1 plus PQ, that is 25 centimeter. So now we know what's OP, we know what's OQ, and we know what's QP. So now we can easily find out what is sine Q. Sine is opposite over hypotenuse. So from reference to Q, the opposite side is OP. So 7 over 25. So sine Q is 7 over 25. Cosine Q, adjacent over hypotenuse. Adjacent is OP, that is 24. So cosine Q is 24 over 25. Hence, we have determined the values of sine and cosine Q. Great. I really appreciate the efforts that you are putting in to understand the lesson. Be focused, practice, keep practicing. The more you practice, the easier it gets. This completes the lesson on understanding trigonometric ratios. In the forthcoming videos, we will study more in depth about trigonometric ratios and its various identities. Until then, keep practicing on these basic trigonometric ratios. Thank you for watching my video. Please share and subscribe and join me in the mission helping you learn. Thank you.